Good day, learners. Welcome to our mathematics lesson for today. My name is Nagile Ndlovu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Our lesson objectives for today are as follows. You should be, at the end of this lesson, be able to draw a graph of any of the trig functions defined by y is equals to a sine k multiplied by x plus p. Those are parameters a, k, and p. By now, you know what we mean by parameters that affect our standard graphs: sine, cosine, and tangent. Some have an effect of shifting the graph upwards or downwards. Some have an effect of moving the graph sideways, either to the left or to the right. And some transformations affect the amplitude of the graph. So we're going to be focusing on such today through drawing and interpretation of those graphs. Then you're also going to look at y equals to a cos k times x plus p, as well as y equals to a tan k multiplied by x plus p for a given domain, which in this case could be x element of negative 360 degrees to 360, or theta, depending on the angle that you are using. Right. You are also going to be able to describe the function in terms of its amplitude, period, and frequency. Then 3, you should be able to answer questions based on those functions: y equals to a sine k multiplied by x plus p, y is equals to a cos k multiplied by x plus p, and y is equals to a times tan k multiplied by x plus p. Right. So we are going to define some of the terms that are found in trigonometry. By now, you should be knowing the definition of trigonometry, definition of sine, cosine, and tangent in terms of our right angle triangle, and the quadrants that are involved, specifically the first quadrant when you are defining these ratios. You should be in a position to plot some points on a Cartesian plane so that you can join them either to produce a straight line graph or a curve or any graph of some kind. By now, I'm expecting you to know some parameters, that is a, p, q, and k, in the following functions, the ones that we have just defined. Y is equals to a sine k times x plus p, y equals to a cos k times x plus p, and y equals to a times tan k times x plus p. Then the definition of range. By now, you should be in a position to identify and define what is range, what is domain, and what is amplitude of a graph. You should also be able to define or identify a line of symmetry and define what is a line of symmetry. Then we also did some general solutions of trig equations at some point in time, and I'm expecting you to be quite conversant with those, because we are going to meet them today as you draw two graphs on the same Cartesian plane. Right. What did we say is domain? Yes. Domain is a set of all the x values for which the function exists. And then range is the set of all the y values for which the function exists. So when we talk of domain, you focus on the x axis. When we say range, you focus on the y axis. Otherwise, the period of a trigonometric graph is the horizontal distance over which one complete cycle of the graph is completed. As you draw these graphs, the three of them, they will always define some patterns. So the wave will start at one particular point on the x-axis and stops again at a certain point on the x-axis, defining a complete wave or a complete pattern. That's what we mean by the period of a trig function. The amplitude of a trigonometric graph is half the vertical distance between the highest point, which is the peak of your graph, and the lowest point of your graph. You find the distance between the 2 points and then divide by 2. It will define what we call the amplitude of your graph. Then a line of asymptote is that particular line on the graph which the graph moves closer and closer to, but will never touch it, even if the graph were to be drawn up to infinity. Okay? Right, so we're going to have a look at some questions today. These questions are going to be done on the same Cartesian plane we are going to be drawing some graphs, and there is a difference between drawing and sketching. When you are drawing a graph, you need specific points through which the graph passes. You literally construct a proper Cartesian plane, and then you plot point by point and then join the points to produce that particular graph. So we want to have a look at the first question, where we are having f of x is equals to tan of x minus 45 degrees. And g of x is equals to cos of 3x for x element of negative 90 degrees to positive 180 degrees, which is a closed interval. After having done that, we are going to determine the amplitude of our graph G, which can still be determined even without drawing the graph. You also need to determine the period of the graph G. Then we're also going to draw graphs of f and g on the same set of axes for x element of negative 90 degrees to 180 degrees, which is our domain. Then we are also asked a question based on the graphs that we are going to draw in 1.3. The question says, for which values of x is f of x minus g of x equals to 1? So we shall have a look and see how that question is answered. Right, but first things first, we want to focus on the first two parts of the question, which say determine the amplitude of the graph G. Right, you will remember when we talk about the amplitude of a graph, we are looking at how far up is the graph displaced from the x-axis. When you are looking at the amplitude of a graph, you focus on the coefficient of the function. It will tell you how far up the graph goes and how far below the graph goes. So when I look at the graph of g of x, which is g of x is equals to cos of 3x. That is my graph g of x. If you check here, the coefficient of x, cos x is a 1. So this is our a is equals to a 1. What does that imply? It implies that the graph is going to start from negative 1 up to positive 1. So therefore, the amplitude of this particular graph is going to be a 1. So meaning the minimum value is going to be negative 1 and the maximum value is going to be a positive 1. Then half that distance means the peak minus the lowest point, which is going to be 1 minus negative 1 divided by 2. It will come back to the same 1. So whatever coefficient you have here, it will always define your or lead to your amplitude of the graph. Right. The next part of the question required you to determine the period of the graph of G. I want you to look at that graph. Cos of x is equals to cos of 3x, and quickly determine for me the period for graph of G. I'm going to give you some seconds to reflect on that question. What does that 3 stand for? Then how would you determine the period of this graph? I can see it's no longer a standard graph. It has been transformed. We have introduced a parameter 3. That 3 is our parameter. It could be kx. In the previous lessons, we called this our k. This was our k. So this is cos kx. Our k is a 3. I want you to quickly identify for me or calculate for me the period of this graph G. Yes, thank you. Right, so our period of the graph, remember we said we always focus on the standard period. So the period for the new graph, G period, the period for this graph, we always take the standard period, which is 360 degrees. Then you divide by your 3, because your k is 3. In other words, this cosine graph is going to make 3 frequencies within a revolution. In other words, it's going to appear 3 times. The same pattern will appear 3 times within a revolution. Then if we divide this, we're getting 120 degrees. That becomes our period. After every 120 degrees from 0, the cycle will be completed. Next cycle, 240 degrees, another cycle is completed. Then the third cycle from 240 degrees to 360 degrees. So this is how you could have determined your A, which is representing your amplitude, is 1, and then your period is the standard period for the cosine graph, which is always 360 degrees. But because of some of these transformations that take place on these functions, we're going to divide our 360 degrees by 3 to obtain 120 degrees. Okay, right. So the next question requires us to draw the graphs of both f and g on the same set of axes for the given domain. X is an element of negative 90 degrees to 180 degrees. I'm going to give you a minute or so, to a maximum of 1.5 minutes, to quickly generate a table wherein we are going to fill in some values here. There are some missing values from negative 90 degrees. We are moving at a step of 30 degrees. By now, you should be again in a position to identify the steps that you need to follow when you are spacing out your angles. You will remember we said, how do we determine spacing? We said spacing of any graph is given by period divided by 4. So the period of our graph cos is 120 degrees. We divide this by 4, it will come to 30 degrees, and hence I chose 30 degrees to space out my angles. Otherwise, if you check the tangent graph, there is a shift of 45 degrees. So to accommodate both functions, I would rather move with a smaller value, which is 30 degrees in this case. So this one, spacing, is going to be is period divided by 4. Remember, the period for the tangent graph is 180 degrees. If you divide 180 by 4, you can check and see what is 180 degrees divided by 4. You'll find that you are getting 45 degrees, same as the shift. So for that reason, I decided to use 30 degrees to space out our angles from negative 90 degrees up to 180 degrees inclusively. So take your calculator, complete that table. I'm going to give you a minute to complete the table. Then when you come back, we are going to complete it together so that you can see whether you are in the right track. And let's make sure we use the calculator. Don't substitute point after point. If probably you haven't been here before and you are not sure as to how it's done, you will try it point after point, substituting one angle at a time. You will see how much time you take. But if you have been here before, you can straight away go to the calculator and punch. Otherwise, let's try to complete that table. Your functions are f of x is equals to tan x minus 45. The other one is g of x equals cos of 3x. All right, welcome back. I hope you have managed to complete that table. Right, let's look at the first function, which is f of x equals to tan x minus 45 degrees. What did you get for your negative 90? I'm getting a positive 1 there. You are going to have a positive 1. The next one is a 3.732. The next value is going to be negative 3.732. Your next value is going to be, that is for 0 degrees, is negative 1. Then for 30 degrees, it's going to be negative 0.257. The next one is going to be positive 0.257. Then at 90 degrees, we've got a 1. And then at 120 degrees, we have a positive 3.732. Then at 150, we are going to have negative 3.732. And then the last one is going to be negative 1. Then when we go to the cosine one, cosec 90, we're going to get a 0. Then the next one is negative 1. The next one is a 0. Then at 0, we have a 1. And then at 30, we've got a 0. Then at next one, we have negative 1. Then we have a 0. And then at 120, we have a 1. And then at 150, we have a 0. And then finally at 180, we have a negative 1. So I guess you can see those values that are shown on the screen there. The question is, how did I obtain these? You need to use your calculator to make it a bit fast. You go to your mode on the calculator. You press your table. For those that were not part of the previous lessons, you press table, that is 3. Then from there, you feed your function. The first function is tan. You press your tan. Then it will open a bracket automatically. Then you say alpha x. You look for x as a variable on your calculator, minus 45 degrees. Then you close. From there, you say equals. The calculator will ask you, where do you want to start filling in this table? You choose your minimum value, which is negative 90 degrees. You press negative 90 degrees. That's your starting point. Then you say equals. Then where do you want to end? Your end point is 180 degrees. Then equals. From there, you have to identify the step. The calculator will always say step 1. That is just but a dummy one. You can as well change it. And in this case, our angles are spaced at 30 degrees each. So we are going to say step 30, then we say equals. Every time after entering, you say equals. After you say enter, it will produce a table that shows all those values: 1, 3.732, negative 3.732, angle by angle. You automatically get the corresponding values of y. The same applies to the cos 3x graph. You are going to do likewise. You punch in the function, command it from negative 90 degrees to 180 degrees with a step of also 30 degrees. Then you'll get those bottom values. Then from there, you can now go and sketch your graphs. Right. Now that we know the x and y values, we'll now go to our Cartesian plane. On the Cartesian plane, we'll space out our angles as shown there and sketch our graphs by plotting the points, point after point plotting. So our first point that we're going to plot is negative 90 degrees versus 1, which is this point up here. That is our negative 90 versus 1. You mark that point. Then you'll remember our cosine graph has got some lines of asymptotes, and you did not see any along the way. So meaning, as you were sketching this or identifying the points that go with these given angles, you should have noticed that the lines of asymptotes are not specified there. You don't see them on the table. So this is where you can quickly go back to your calculator and space out using 45 degrees, which is the standard spacing in a normal tangent graph. So you are going to say tan of alpha x this time minus 45 degrees. Then you follow the same steps from negative 90 up to 180 degrees. But this time around, I want you to space using 45 degrees. Because we have seen that when we are spacing using 30 degrees to accommodate cos 3x, we don't see lines of asymptotes. We'll end up drawing a tangent graph that just continues and is unbounded. Yet we know the tangent graph has got lines of asymptotes. So the question is, how do I identify lines of asymptotes? You will remember the standard period in tan is undefined. Is 180 degrees. So our period in tan graph, so we're saying our f of x is equals to tan of x minus 45 degrees. If you were to space this using 45, in other ways, the spacing is equals to period divided by 4, only for the tangent graph. This is going to be 180 degrees divided by 4. You are getting your 45 degrees. meaning if we're drawing only this graph alone and not comparing it with another graph, then we were going to space it out using 45. So if you space it out now using 45, you'll find that you'll be able to identify your lines of asymptotes. So you go back to that tangent graph and press a table, then you get your function f of x, and you feed the function tan x minus 45 degrees, and then say equal from negative 90 degrees, then end at 180 degrees. Then from there, your step this time will be 45 degrees specifically for the tangent graph. That will enable you to see which ones are lines of asymptotes, which are those broken lines, vertical lines, which the graph is not allowed to cross, or neither is it allowed to touch. That's our lines of asymptotes. So there are some scales that we can choose, especially when you are comparing graphs that don't show lines of asymptotes. So that being the case, there is no way you can have a tangent graph from negative 90 to 180 degrees and there are no lines of asymptotes. But our table did not display those lines of asymptotes, wherein on your calculator you will always see error, error, error. What does that mean? It means there is no y corresponding value at that particular angle. So in this table, we did not experience that, meaning is probably some angles that were hidden, like an angle like 45 degrees, 135 degrees, which is between 120 and 150, an angle between 30 and 60 is 45. Maybe those are the angles that are carrying my lines of asymptotes. What then do I do? Like I've already explained, you take your standard period for the tangent graph, divide it by 4, so that you know if I were to draw this graph alone, what would be the lines of asymptotes. You'll find that when you feed this information on your calculator, this time around, you are going to be able to identify between negative 90 degrees and 180 degrees which lines are lines of asymptotes, or which angles will lead to lines of asymptotes. Right. After doing this, I'm getting negative 45 degrees, which is between negative 30 degrees and negative 60. That's my first line of asymptote. Then the next line of asymptote will occur, if I scroll down my calculator, it will occur at 135 degrees, between 120 degrees and 150 degrees. Those two in this interval or in this domain become our lines of asymptotes, meaning our tangent graph won't be able to cross those vertical lines of asymptotes. Right. So what are we then saying? As we plot these points, you will find that the first point that we plotted is at negative 90 degrees versus 1, which is there. Then obviously the graph is going to move closer and closer towards that line of asymptote as denoted by that arrow there. Then you continue plotting all your points up until all of them have been plotted. For example, when x is 0, our y is a negative 1. We mark that point. When x is 45 degrees, the graph crosses the x-axis, and so on, marking all those points like 3.73. Remember, we said when x is negative 60, y is 3.73. So we're going to estimate that when x is negative 60, y is going to be 3.73, which is further up the axis. When x is 60 degrees, we go to 60, our corresponding y value is going to be 0.25, meaning when we are somewhere up here at 60 there, this is our 0.25 there. We plot all those points going up until all of them have been plotted, angle after angle. 90 degrees is further up there. Then you can see the graph is getting closer and closer towards the vertical asymptote of x is equals to 135 degrees. So this is a cosine, a tangent graph that is trapped between negative 45 degrees and 135 degrees. But since we have a closed interval of domain from negative 90 degrees to 180 degrees, we may not see the other lines of asymptotes. Otherwise, they will come after a certain number of degrees, which is after every 180 degrees, we'll always find a line of asymptote as we move forward or backwards. But today's domain is restricted from negative 90 to 180. So the first branch of our tan graph will start at negative 90, which is when y is 1. Then it will continue up to closer and closer to the line of asymptote, which is negative 45 degrees. This is your x is equals to negative 45 degrees. And this one here is your x is equals to 135 degrees. Those are our lines of asymptotes. That is our tangent graph. Then likewise, we're going to draw the cosine of 3x. What you'll realize here with the cosine of 3x, cos of negative 90 is 0. Then cos of 60, we mark here, that is our negative 1. Then 30 is 0, you mark those points. And then at 0 is 1, is up there. Then at 30 it comes down, it crosses. Then at 60 is further down here. And then at 90 it crosses. Then at 120 is up there. Then at 150 it crosses. At 180 is at negative 1. The same applies to the tangent graph. At 180 it was a negative 1. Right. So this branch of tan goes down. On the other hand, it goes up. Right, because they are moving closer and closer towards our lines of asymptotes. Then when we join these points for the second graph, we are producing a smooth cosine graph, which is trapped between our negative, let me choose a color, different color for you. Right, this graph is trapped between negative 1 and positive 1, like that. So it means our range is negative 1 to 1. So we have drawn two graphs on the same Cartesian plane, and what we are observing as we analyze these two graphs is that they meet at this point. That is a point of intersection. You can literally read the answer and estimate it as close as possible because this is a proper diagram. It's a drawn diagram. It's not a sketch because I used a proper graph paper to draw the graph, meaning I can so long read this answer where these two graphs meet. They meet again at 180 degrees. When x is 180 degrees, the two graphs will meet. So in this interval of negative 90 degrees to 180, we see these two graphs meeting twice. They meet at this point that I will call point A. They will meet again here at point B. So when they meet at B, our x value is 180 degrees. When they meet at A, is before 45 degrees, which is around 40 degrees or 30-something degrees. You can read according to the scale if you are asked to identify the coordinates of A. Why are you able to read? Because this is a drawn graph. It is not a sketch graph. In a sketch, you just spacing out angles the way you want, but there is no specific reading of points. There is no proper scale. Here, there is a proper scale. I can as well read the answer from the graph. Right. This is how you could have drawn these two on the same Cartesian plane. Tangent graph versus the cosine graph. Right. What you should realize again based on the previous lessons, when I look at this tangent graph cosine graph from here, it goes down, further down, then it turns, and then it goes up, right? Then it goes further down, and it stops there in the given interval. This is not a revolution. This is exactly 180 degrees. So already I'm seeing one complete wave from this point here up to that point. Is a complete wave because this graph is making a V-like shape. Then it starts again at the top going down. If we continue up to 360, you'll realize that there is going to be 3 complete waves. But today you won't be able to see those 3 complete waves because of our domain. But all we are saying here is that if this is cos 3x, the frequency of this cosine graph is going to be 3 within a revolution. But unfortunately, we cut it short at 180 degrees. Right, what I realize here is that at this point B, we have the red graph versus the purple graph. That is what we mean by a common point. That is a point of intersection. This is where the two graphs will meet and cross each other, same as at point A. Otherwise, at negative 90, the graphs are at two different points, which is point D up there and point E down here. There is a gap between the graphs at that particular point. They don't touch each other. There are many points on the interval given or on our domain where we have a gap between the tangent graph and the cosine graph. But it now depends on what type of a question is posed or asked. If I go back to my questions now, the last question there said, for which values of x is our f of x minus g of x equals to 1? What does that mean? I want you to quickly find on the sketch here which values of x is f of x minus g of x equals to 1. How do you interpret that question? I'm going to give you some seconds to look at the sketch and identify a region on the sketch where the gap between f of x and g of x is exactly 1 unit. Let's try that question. This is what we call the interpretation of graphs. How do you interpret your two graphs that have been drawn on the same Cartesian plane? Yes, let's look at that graph. Identify a region where f of x minus g of x is equals to 1. You also need to have an understanding of what that statement implies. Yes, thank you. According to my sketch here, I need to look for a region where the gap between f of x and g of x is a positive 1. You're basically looking for a region where f of x minus g of x, I'm trying to create space for you here for us to write. What does this mean? It means we're looking for f of x minus g of x is equals to 1. This implies that look for a region, a vertical distance. Remember, these are y values that you are focusing on. F of x is y and g of x is another y. So we are subtracting two y values and we want the answer to be 1. And one graph that is above is f and the other graph must be g. Both graphs must be involved. If you look at this region here, DE, the y value at that point is a 1 and the y value of the g graph here is a 0. This is where I see a gap of 1. That is a gap of 1. If I say upper value there is a 1, lower value is a 0, because they want me to pick a value from the f graph, then subtract a value from the g graph, but the answer should be a 1, exactly 1 between those two. We are looking at the vertical distance between the two graphs where the answer or the gap is a 1. So I see at point D and E that I've added on the sketch where the tangent graph starts and where the cosine graph starts at negative 90 degrees. I see that gap is a 1 between the two graphs. Right, again, if you go to positive 90 here, I see here, this is our f graph is at 1, but our g graph is at 0. Let's call this T and U. So there were two positions where we have a vertical distance which is 1. It's when x is equals to negative 90 degrees. That's where f of x minus g of x have a gap of 1, because the upper value is a 1 and the lower value for the other graph is a 0. And again, at positive 90 degrees, our f graph is at 1, our g graph is at 0. So when a question says determine for which values of x is f of x minus g of x equals to 1, that 1 is just but a numerical value, which is a vertical distance. Why are we focusing on the vertical distance? Is because f of x is y and g of x is also another y value. So we're basically comparing the two graphs to look for a region which is a vertical distance where the gap between the two functions is a 1. So we are saying this is happening when x is equals to negative 90 degrees. Our g of x is at 0 and our f of x is at 1. So when we subtract those two, it's going to be 1 minus 0, which is equals to 1, which confirms that gap of f of x minus g of x is equals to a 1. Again, at positive 90 degrees, we see our f is at 1 and our g again is at 0, which is our distance tu. This vertical distance tu down there, this is our tu. That distance there is exactly 1 unit. That distance there is also 1 unit. So those are the two positions where our graph is having, or the difference between those two graphs is a negative 1. Okay. Right, let's move on. We're moving on to our next example. This example is saying given f of x is equals to negative 2 sine x and g of x is equals to cos of x plus 30 degrees for x element of the domain negative 90 degrees up to 180 degrees, same as the previous domain. And we want to draw this graph on the same Cartesian plane, but before we draw these graphs, let's get used to finding the frequency of the graph, if it ever has a frequency, and then we find also the amplitude and the period. Sometimes the periods get affected. Just discussing those two, I want you to quickly check the frequency for me for each graph, and then you also look at the period for each graph before we can even answer any question. You need to be able to interpret the function itself before you can even draw the graph. Hence, I have my 2.1 saying determine the amplitude of graph f for 1 mark, then determine the period of graph g for 1 mark also. Yes, the amplitude for graph f is going to be a 2. Yes, we're seeing a negative 2. We know what that negative 2 implies. It means that sine graph was doubled and then reflected on the x-axis, then it became negative 2 sine x. That's actually a reflection across the x-axis because it's affecting the y values. What should have been a 2 is now a negative 2. So meaning we reflected the graph of sine 2 sine x on the x-axis, then it became negative 2 sine x. So our amplitude is reliant very much on the coefficient of the function. The coefficient of the function in this case, if we were to look at the absolute value, is a positive 2. So our amplitude will then become a positive 2. Okay. Then when we look at the period of graph G, let's look at graph G. Graph G says cos of x plus 30 degrees for x element of negative 90 degrees up to 180 degrees. Now, when you go into the bracket, I see here in the bracket, we have x plus 30 degrees as our angle. Otherwise, this is cos of x plus 30 degrees. When you look at the coefficient of x here, it's a 1. Since the coefficient of x is a 1, it means the period is not affected. Our period is still going to be 360 degrees divided by our k. Our k is 1, which will give us the same 360 degrees. That's our period. So what are we then saying? We are saying our amplitude is equals to 2. 1 mark for that. I hope you got that 1 mark. Amplitude will never be a negative number. It's the upper value, which is going to be your positive 2, and the lower value, which is going to be your negative 2. How did we get that 2? We say upper value is going to be 2 minus negative 2, then divide by 2. Remember, we're always saying half the distance. Amplitude is always half the distance between the highest value and the lowest value. So the lowest value of our graph is going to be negative 2, and the highest is going to be a positive 2, based on the coefficient of the function. Then 2 minus negative 2 will give us a 4. Divide that 4 by 2. The formula is always half that distance. Hence, you get your amplitude is a 2. Then the period, we already have agreed that the period, you take the standard period for the cosine graph, then you divide by your k. In this case, our k is still 1, meaning this period will still be 360 degrees. Like before, I want you to quickly complete this table on your own. Quickly complete the table. There are some calculators that can accommodate both functions at the same time. So step number 1, what do you do? I'm going to guide you through so that you finish off the table on your own. Step number 1, you fit in your functions. Our first function, you press table on your calculator. First of all, you say mode, switch it on, mode, then table. That is 3 according to my calculator. Then the screen displays f of x. Then f of x equals 2. You enter your function. The first one is negative 2 sine of x. You use alpha x, then you'll have your function. Then you say equals. It will ask you where do you want to start, from negative 90 degrees equals, and at 180 degrees equals. Every time after entering a particular number or variable, you press equal. That's how you enter on your calculator. Then from there, step, right, again, you have to work out your step here. I see there is a shift of 30, so I would rather stick to a shift of 30. So I'll say step 30 degrees and say equals. Then you'll have your table. Right. We then complete our table. Negative 90 for negative sine 2x. Negative 90, we're getting 2. At negative 90, we get a 2. Then at negative 60, we get 1.7. Correct to 1 decimal place, but correct to 2 decimal places is 1.73. Then at negative 30, you continue and so on and fill in all those angles on your own. Fill them in. Yes, let's work, boys and girls. Let's work. Fill those angles in. I mean the corresponding y values under f of x and g of x. If your calculator takes both at the same time, you'll find that you'll have 2 tables at the same time. But if it can take one at a time, rather fit your first function negative 2 sine x, then complete the table, go back, fit the other function, and also complete the table. Yes, there are our first values for the first function, negative 2 sine x. Then you go back and do the other function, which is your cos of x plus 30 degrees. Plus 30 degrees. Let's confirm that, yes, cos of x plus 30 degrees in the same interval. So you just fit cos x plus 30, alpha x, then add 30, close brackets, and then proceed. Equals to, start from negative 90, 180 degrees is your end point. Your step is still 30 degrees. Then you'll get the corresponding values of y. The first one is 0.5. 0.5. The next one is 0.866, which you can also round up to 0.87. 866. When you plot, you can use 0.87 or close to 0.9. Then the next one is a 1. Negative 30 is a 1. Actually, yes, negative 30. Negative 60 is 0.866. Let's go back to negative 30. Okay, there is my negative 30. I get 0 point is a 1. Then the next one, 0 is 0.866. Let me quickly check. I mixed up my stuff here. Negative 60, 0.866. Then the next one, negative 30 is 1. Then 0 is 0.866. Then 30 degrees is 0.5. Your next value, 60, is 0. Then the next one is negative 0.5. Then the next one, 120, is negative 0.866. Then the next one, 150, is negative 1. Then the last one is negative 0.866. Those are the corresponding values of y on this cosine graph. So you'll get some marks for completing your table. If you are asked to complete, at least 1 mark for each or 2 marks for each. Otherwise, the most important part here is the sketching or drawing part of it. But for you to collect all the marks, make sure you are careful on the calculator. Don't rush things, because so many questions will still follow after you have drawn the graphs. So having calculated your points, you now go to your Cartesian plane and then plot all your points, point after point plotting. You will find that these two graphs will meet at some points. They meet already here at negative 30. They meet again at negative 150. They are sharing those y values at that time. If you check on your table there, at negative 30, they are both showing a 1. If I can highlight this here, both graphs share 1. Even at 150, they both share negative 1. Already this indicates that these are my points of intersection of the two graphs. So having completed this, you are going to mark again point after point, those points that you obtained on your calculator. The first point being negative 90 versus a 2 for the first graph, which is this point. The next point is negative 60 versus we said 1.73. The next point is going to be 30 versus negative 30 versus 1. You mark all the points all the way down until all your points have been plotted. You plot all the points. This is what we mean by point after point plotting of the graph. Then from there you join using a smooth curve. We join using a smooth curve. This is a cosine graph that has been reflected on the x-axis. Otherwise, under normal, this portion of the graph is at the top. But because of that negative 2x, it means it is a reflection on the x-axis. Hence, we see this part of the graph in the fourth quadrant. What was in the third quadrant goes to the second quadrant. What was in the first quadrant goes to the fourth quadrant because of a reflection. That graph is a sine graph that was doubled in size. In other words, we multiplied, our a became a 2, the graph doubled in size, but because of negative 2, it means we have reflected that graph on the x-axis to define the new graph, that red graph that we are seeing. Then again, we're going to plot the other graph, negative 90 versus 0.5, and so on until we get to the last point. So point after point, we will mark this point here. We mark that point there. Negative 30 goes with 1. We mark they meet there. Then 0 is 0.866. Then we go to 30. It goes to, we said 30 goes with 0.5. It comes back to 0.5. You mark all your points until they've all been plotted on your Cartesian plane up to the last point. Then you join them using a smooth curve. At the end of the day, this takes us back to functions in general to say when two graphs meet at a particular point, it means they are equal at those points, which takes us back to algebra when you are solving simultaneous equations to say, what does that mean? It means graphical. This is where two graphs meet at a particular point and share a particular x values. So when x is negative 30, the graphs meet. When x is positive 150, again the graphs meet. Therefore, in the given domain, negative 90 degrees up to 180 degrees, we realize that the two graphs meet twice. They meet at negative 30 degrees, they meet again at 150 degrees. Right. This is how you could have drawn those two graphs on the same set of axes. But what is important here is to be able to identify the steps as you draw that particular graph. How am I going to space out my angles? The calculator will always say step 1, but you look at how you spaced out your angles, you replace that 1 and put 30 degrees in this case. If tan is involved, this is where I said you have to go back to the standard tan based on the period of that graph you are drawing so that you are able to identify your lines of asymptotes. But these two graphs don't have lines of asymptotes, so if I space them out with 30 degrees, both graphs will exist because I'm not worried about lines of asymptotes. These are just but complete smooth waves from negative 90 degrees up to 180 degrees. So this could have earned you a total of 6 marks, 3 marks for each graph. So you'll get 1 mark for the shape of the red graph, 1 mark for the intercepts. It could be the x-intercepts, then the y-intercept. 3 marks for that. Then you draw the other graph. After all, you can even mark the turning points here. Are your graphs turning at the correct points? Are they stopping at the correct points? Yes, so you'll get 1 mark for the shape, correct shape. It must take this wave-like shape. Then at the same time, it must have some turning points. And also, there has to be some intercepts with the axis. So our red graph crosses the x-axis at 0. It again touches the x-axis at 180, but it won't cross because it's a closed interval. That's why the ends are logged for both graphs. They are shaded at the ends. It shows that it's a closed interval. Okay, right, so our next marks will be, of course, for the other graph. It will also carry 3 marks. 1 mark for the shape, 1 mark for the intercepts, and 1 mark for the the turning points. Then you'll get a maximum of 6 marks there. Then we go back to the other question, which said, use your graph to determine the values of x for which f of x is equals to g of x for 2 marks. You look at the sketch. I want you to look at the sketch and identify the values of x where the two graphs f of x is equals to g of x. Where is f of x equals to g of x? We need to answer that question. Let's go ahead and answer it. And remember, when you are dealing with angles, you must attach the units there. Degrees. Don't just write 120, 90. You have to specify 90 degrees, 120 degrees, and so on. Yes. Please don't be carried away and start equating those two functions to solve for x. The question said, use your graph to determine the values of x for which f of x is equals to g of x. The graphs already indicate where those two or where they meet. They meet at some point here, A. They meet again at some point there, B. These 2 points. That's where f of x is equals to g of x. So you have to identify now the x values. Determine the value of x for which f of x is equals to g of x. They didn't say write down the coordinates of the points of intersection. That could be another question. Yes, in terms of coordinates, you are going to identify this point as your point A is negative 30 degrees versus 1. Then you come to this other point B. The coordinates are 150 degrees. We always start with the horizontal and then negative 1. Those are the points now. If the question required you to determine the coordinates of the points of intersection, this is how you could have answered the question. But otherwise here, the question asked you of the points or x values where the two graphs are equal. So the two graphs are equal according to my sketch here when x is a negative 30 and when x is equals to 150. Therefore, your answer is x equals to negative 30 degrees. 1 mark for that. And the other one is when x is equals to 150 degrees, another mark. Well done. I know you got that one. Keep it up. We're cruising. That's wonderful. Right. We're moving on to the next question. This one is very interesting because it's a typical examination type of a question. It's a past examination type of a question. Right. This question says, determine the general solution for sine x minus 30 degrees is equals to cos of 2x. This is an equation. This is general solution. I'm going to give you 2 minutes to a maximum of 3 minutes to work out the first part of the question, which says determine the general solution for sine x minus 30 degrees is equals to cos of 2x. The first 5 marks of the question. Let's start now. I'm going to time you. I'll give you, usually if a question carries 5 marks, you must not exceed 5 minutes. Always work it out that way. If it's 5 marks, spend 5 minutes at most. If it's 1 mark, try to spend around 1 minute. So this one is 5 marks, spend at most 5 minutes going through this question. I'm going to give you those 5 minutes, work out the question and see where are the two equal. They said general solution. Let's determine that general solution. Let's have a look at how you answered that question. Hopefully you managed to go through and got some general solution there. Right. The first part of the question says, determine the general solution of sine x minus 30 degrees is equals to cos 2x. So we'll say sine of x minus 30 degrees is equals to cos of 2x. You'll remember we said in these types of questions, this is where we are going to use co-functions. Otherwise, the functions are not balanced. You can't even create tan because the angles are not the same. Yes, the coefficients are the same, 1, 1 on both sides, but the angles are not the same. So we will convert one function to the other through co-functions. So if we say sine of x minus 30 degrees is equals to sine, the moment I say sine, on the other side, I must now introduce 90 degrees minus 2x. You subtract 2x from 90, then it becomes a co-function. So we have converted cos 2x to its co-function, which is 90 minus 2x. Now that the functions are the same, is sine and sine on both sides, we are going to equate in angles because we are told these two functions are equal. Therefore, x minus 30 degrees should be the same as 90 degrees minus 2x plus k 360 degrees, which is the period in sine. Then from there, we rearrange group-like terms together and solve for x. Then we are going to get 3x is equals to 120 degrees. If you move negative 30 to the other side, it becomes positive 30 plus your k times 360 degrees. Then you divide both sides by 3. Therefore, your x is going to be 40 degrees plus k times 120 degrees. For k element of integers, you have to qualify your k. So step number 1, you convert cosine to sine through co-functions so that the functions read the same. We haven't finished because this angle is in the first quadrant where sine is positive. Or the other solution you go to the other quadrant. This is where it becomes a bit tricky, because there has to be a reference angle that you are using. So my reference angle in this case, I'm going to take this angle here. I will call this my reference angle, 90 minus 2x. I now want to go to the second quadrant where sine is also a positive. Then what am I going to say now? I will say x minus 30, I will keep it as x minus 30 degrees, equals to 180 degrees minus this angle of mine, which is 90 degrees minus 2x, right? Plus k 360 degrees, plus k 360 degrees. Then again, you remove brackets, you will get x minus 30. Okay, let's just move this part here. We get x minus 30 degrees is equals to, we subtract on the other side, we remove brackets, we get 90. 180 minus 90 is 90, and negative positive 2x. Then plus your period k, 360 degrees. Then you proceed and solve for x. You group like terms together. X minus that is going to be negative x. On the left hand side, I'm moving my 2 to the other side. It's going to be x minus 2x, negative x. Then I'm moving my 30 degrees, negative 30 to the other side. Is going to be 120 degrees plus k 360 degrees. Then you divide throughout by negative 1. Our final answer will be x is equals to negative 120 degrees minus k 360 degrees. K can change to a negative depending on what coefficient you are using to divide. So this is the other wing, which is now in the third quadrant. 180, negative 120 degrees is the same as 240 degrees. So for k element of integers, this is how you could have found the general solution. It means there are two sets that generate those angles where the two functions are equal. It's 40 degrees plus k 120 for k element of integers being your first one there. Then the other one is going to be x equals to negative 120 minus k times 360 degrees there. I mean negative 120 minus k times 360, yes. So that's how you find the general solution of the equation that was given, right? Maybe another learner would have loved to use a different approach altogether by using, let's say you want to use cosine. Let me quickly remove this. We'll come back to those that would have loved to use the cosine, right? Let's go straight to this cosine one. Somewhere, let me put it somewhere here for cosine. Those who would have loved to use cosine. Those, right, you are going to say our sine of x minus 30 degrees is equals to cos of 2x there. It's a learner who chooses to convert to cosine, co-functions. You go to the left-hand side and change sine and introduce cosine. Once you introduce cosine, you involve 90 degrees minus x minus 30 degrees in case you approached it that way, right? This is an alternative approach, equals to cos of 2x. Now that the functions are balanced on both sides, we focus on the angles. We are having 90 degrees minus x minus, actually plus 30 degrees. When you remove your bracket, it's going to be plus 30 degrees is equals to 2x. Then you solve for x plus k element of integers. K 360 degrees where k is an element of integers. Then we're solving for x here. We're going to move 2x and get negative 3x. Then we move 90 to the 120 to the other side. It's going to become negative 120 degrees. Then plus our k times 360 degrees. Then we solve for x. We'll get x equals to 40 degrees plus k multiplied by negative 120 degrees. Remember, we're dividing both sides by a negative 3. Therefore, our final answer is what we have here for k element of integers. Alternatively, you can also, actually, we need to finish off the other side and say, or you need to identify your reference angle this time. Our reference angle is 2x here. That's our reference angle, 2x, for the other side where these two functions are going to be equal. Remember, at any given time, there are two quadrants that are affected. So 40 degrees is in the first quadrant. Where else is cosine a positive? It is in the fourth quadrant where the angle is negative. So we must take advantage of that and say, I'm going to say on the other side, I already know is 120 minus x on the other side. When you remove brackets here, that's 120 minus x degrees. So it means our 120 minus x degrees should be equals to negative 2x. Our 120 minus x degrees is equals to negative 2x. Instead of saying 360 minus 2x to go to the fourth quadrant, we can as well remember that cos of a negative angle is the same as cos of the positive angle. This is what I'm referring to. If I say cos of theta is the same as cos of negative theta, that's what I'm talking about. I'm taking advantage of that. Cos of a negative angle is the same as cos of that same angle. Right, so my angle is 2x. 2x will now be represented by negative 2x, in as much as theta is represented by negative theta. When you are using cosine, the result is the same. So I now have 120 minus x is equal to negative 2x. Then I solve for x. I'm getting here, we're moving the 120 across and bring x. X becomes 120 degrees plus k 360 degrees for k element of integers. So for those of us who used this approach, you will also come back to the same answers. You can either convert to sine or convert to cosine in your core functions. Right, that's how you could have attempted this first part of the question, which says find the general solution for 5 marks. I hope you got that correctly. Then let's have a look at how the marks were allocated here. They are saying 1 mark for that conversion cofunctions, 1 mark for forming the equation, 1 mark for this first general solution for k element of integers, and then 1 mark for the next solution where you now focus on the second quadrant where sine is a positive. Then you'll get your 5 marks for k element of integers. Don't forget to indicate that the elements k is an element of integers. Right, the next part of the question says write down the period of graph G. Then we look at graph G. Our graph G is this one. They've now separated the functions and made them separate graphs. Our graph G, we look at the period, is f of x is equals to the first graph. Otherwise, the next graph says g of x. So we want to find our period for graph G. Our g of x is equals to cos of 2x. Therefore, our period is going to be, let's work out the period quickly. What's the period for that graph? It can't be 360 anymore because of that 2. Yes, you are going to say 360 degrees divided by 2. Then what we obtain? We obtain 180 degrees, meaning our cosine graph is going to make 2 movements or complete patterns within a revolution. It is a cycle or a frequency of 2. The first cycle ends at 180, the next cycle will end at 360 degrees. Then the next part of the question says, determine the range of graph f. When you look at graph f, the coefficient of that graph f is a 1. F of x equals to sine x minus 30 degrees. Our coefficient is a 1. Therefore, our range for that graph is going to be, let's quickly get to the range. Allow me to write here, range of graph f is going to be, it implies our y is an element of -1 to 1. We are taking advantage of that coefficient, which is a 1. Okay. Then 6.3 now, you are asked to, on the same grid provided in the answer booklet, you'll be given a grid. Draw the graphs of f and g for x element of -90 to 180 degrees, and clearly show all your intercepts with the axes. This is again where you are going to complete the table first on your calculator and fill in all the values there. So we take our calculators. The first function is x, sine x minus 30 degrees. You must punch in the correct things. Is sine x minus 30 degrees. So we're going to press sine, then alpha x degrees minus 30 degrees. Then you enter from -90 up to 180 degrees. Our step is 30 degrees. Then you proceed and obtain your corresponding values of y. And obtain your corresponding values of y. And then we complete the table. So for the first function of sine, this is what we are going to obtain. You are going to get -0.866 followed by -1 followed by -0.866. You can see it's coming back now, followed by at 0 you have -0.5. Next at 30 you have got a 0 is crossing the x-axis. Then next is 0.5. It's like it's a pattern of some kind. Next is 0.866. The other one was -0.866. This one is now positive. The next one is a 1. The next one is 0.866 at 150. Okay. Then the last one is 0.5. Then you move on to the other graph. This time your other graph is going to be cos 2x. You fit your cos to alpha x, then you close. Cos open bracket 2, then alpha x, then close. You'll have your 2x. On the same domain, -90 to 180, then step is still 30, then you will retrieve your values. Right, at -90, I have a -1 there. I have a -0.5 here. Then next, I have a 0.5 at -30. -30 is a positive 0.5. Then at 0 degrees, we have a 1. Then you proceed at 30, you have a 0.5. Then at 60, you have a -0.5. Then at 90 degrees, you have -1. And then at 120 degrees, you have -0.5. These are your y's corresponding values. Then final, you have you have a positive 1. At 150, let's check 150 is a 1. And then the last one is our, let's check quickly, my 150 0.5. 0.5. And then my last one is a 1. Right. Thank you. That's your table. And that's how you could have completed that table. Yes, there is a question that has just been posed. Let me quickly clear that question. I see you have a question which says, does it matter even if I say plus k 360 or plus 360 times k? It really doesn't matter. You can say 360 multiplied by k. I know where you're coming from. You're coming from algebra to say in algebra, we always start with the coefficient and then end with the variable. That's a very good observation. Yes, there is nothing wrong with that as long as you put a multiplication sign. 360 times k is fine, even if you say k times 360. But you must be careful when you divide by a negative, that 360 can change to a negative 360 or negative 120. So don't be surprised to see some of these questions where there is that k element having a negative. It's because we are dividing by a negative coefficient, and that alone does not affect your solutions. You can still get to the same solutions. Thank you for that question. It doesn't really matter where you place your k. But what is important is in general solution, even in particular solution, you have to start from general solution, attach that k, then use k to search for the values of x that make the equation true. That's when you replace your k. So honestly speaking, it doesn't matter where you place a k. But most of the times we normally say times k 360. It's the same as saying 360 times k. Well done. Okay, so there is our table is complete. We now want to move on and sketch the graph. So sketching the graph, of course, would require you to plot the points. We saw earlier on that at negative, I will start with the first graph, which is graph graph f. Our graph f, we said, is the sine x minus 30 degrees. So it's the blue graph. Right, so at negative 90 is down here. Then you mark all your points. You mark all your points, point after point plotting, point after point plotting. You plot all of them until you are done. At 150 is up there. At 180 we saw is 0.5. If you remember, at 180 is 0.5. At negative 90 is negative 0.866. At 30 is 0, meaning at 30 is crossing the x-axis. Then you join those points to produce a smooth curve in that given domain. Likewise, you go to this other graph, cos 2x. It starts at -1, it goes to negative 0.5, then and so on. So at negative 90 is down here, at negative 60 is negative 0.5, then it crosses here, then at 30 is up there 0.5, at 0 is at 1, then it comes back to 0.5, then it crosses here, then it goes to 60, that is your negative half, then it continues to the turning point and so on. You mark all your points until you mark the last point, which in this case is 180 degrees versus 1. Once all those points have been plotted, again you join the points to produce a smooth curve. So these graphs will meet now at two different points. They meet here. I don't know where they meet, to be honest, but I can read, although it won't be accurate. They meet again here. I'll call this point B. They meet again here, third time, point C. This is where the two graphs meet. Okay, right. So having said that, what's the next question? I've drawn the graph for those marks. Then the next question says, that is worth 5 marks drawing of those two graphs. Write down the coordinates of the points of intersection of the graphs. This is where you'll need your general solution. Your general solution said your x is equals to 40 degrees plus, it was 40 degrees plus k, 120 degrees. You are going to generate the points where they meet. Then you move on to another solution. It said negative 120. They meet again at negative 120 degrees plus k times 360, negative 360 degrees. This is what you are going to use because the answers are not obvious today. So these graphs meet just before a negative 90. You need to find where exactly is that. They meet again after 30 degrees. So after 30 degrees, you come to the first general solution. You substitute and use k equals to 0. When k is 0, what we notice? This disappears and you are left with 40 degrees. So at B, we have 40 degrees. We can find the corresponding value of y on that graph. by substituting into any of the two functions. Preferably, I'll substitute into the cosine one. It said cos 2x. So I'll use cos 80 now. What is cos 80 degrees? It gives us 0.17. So this goes with 0.17, that point. That's where they meet. The next point, I'm going to use a -1. I'm going back because if I go to k is 1, it's going to be 120 degrees plus 40, which gives us 160, which is still fine because it's still within my domain. When I use in this first general solution, when k is 1, I'll put 1 times 120 here. I get 120 plus 40, I get 160. So they meet again here at c, which is 160 degrees, versus I substitute 160. I say cos of 2 times 160 degrees, then get the corresponding value of y, which is 0.77. They meet here at 0.77, correct to 2 decimal places. Correct one is 0.8. So I found 2 points where they meet. How am I getting these intersections? I'm using general solution. Then when I use a -1, it means I'm now going backwards on the same general solution. So when I use -1, it's going to be -1 times 120. I get -120. I then say, what is 40 degrees minus minus 120? I'm getting -80. So it means this point A here is -80 degrees, which is just before 90. Then I substitute, I say, because they meet there, I'll use the simplest equation of the two, which is cos 2x. I then say cos of double -80 degrees, which is -160. Then get -0.93, which is actually -0.94, correct to 2 decimal places. So these graphs meet at those 3 different points. We used the general solution answers to allocate points to A, B, and C. Now that all 3 have been exhausted, I don't have to look at the next general solution. All the answers that I wanted have been generated, and I know where they meet in those 3 different positions. They meet after 30, which is 40. They meet after 150, which is 160. They meet after -60 before -90, which is -180. This is how we use general solution versus the sketch, especially for those questions where 2 graphs meet is not obvious. You have to use general solution to identify where exactly were they meeting. Otherwise, it's going to be a rough sketch. Okay. Right, I guess we've exhausted those questions. We have exhausted those questions for 3 marks. And then my next solution, oh yes, before I go to the next part of summarizing this work, there is a question where someone is saying they didn't understand how you get the lines of asymptotes. I indicated earlier on that if you choose a particular interval to accommodate both functions, in this case I chose 30 degrees. That was when you were talking of this graph here at the beginning, lines of asymptotes. How did I get those lines of asymptotes on this particular graph? This is the graph that you are referring to. When you check here, we are moving at an interval of 30. And once we move at an interval of 30, you will fail to get the lines of asymptotes. But at the same time, you are accommodating the other function that is a shift of 30. So the best is always to move with the smallest angle of them all. So that being the case, what are you going to do? You are going to go back to the cosine graph alone, which is, let me quickly come here. Your cosine graph, your tangent graph was saying, let's say it was f of x is equals to tan of x minus 45 degrees. You look at the period of this graph, it is 108. It's a standard that shifted forward by 45 degrees. A minus 45 means the graph shifted forward. A normal tangent graph moved forward by 45 degrees. But its period is 180. Right, you take this period, you divide by 4 to get your spacing, right? This gives us 45 degrees, meaning if we're drawing this graph alone, we could have spaced it out using 45. So to answer your question, I'm saying you go back to your calculator and feed this function and move at a step of 45 degrees instead of 30 degrees. Once you move at a step of 45 degrees, you'll then be able to identify your lines of asymptotes. Otherwise, if you move with a step of 30, you'll be able to identify any other points there, but you won't be having lines of asymptotes. But the question is, why then did we move with a step of 30? There was a shift of 30, which happens to be the smallest angle of the two. So like I'm saying, if you were drawing tan graph alone, you would have moved with 45. You are going to clearly and immediately see your lines of asymptotes. But now that you are comparing it with another graph, you are forced to move with a step of 30 to accommodate that. So in that domain, there was no lines of asymptotes. That's why you were forced to go back and work with 45 to identify your lines of asymptotes on the calculator where it says error. Okay, I guess I've answered you. Right, I'm coming to the conclusion, boys and girls. We are saying in this lesson, we were looking at how we draw graphs of any trig functions as defined there by using what we call point-by-point plotting. And secondly, we were describing the functions in terms of their amplitude, period, and frequency. We interpreted those effects of A, K, and P, those shifts, those movements. We also had a look at general solution along the way, and then we drew those functions and interpreted them in terms of their periods. But of interest is to take note of the following. The period of a sine graph and cosine graphs is always given by 360 degrees divided by k, whatever coefficient of the variable you have there. You divide into 360, you'll know the period of that graph. Otherwise, for the tangent graph, you divide 180 by the k to know the new period of your graph. Here is your worksheet. You need to answer those questions. It's a total of 14 marks. You are given that f of x is equals to cos x plus 60 degrees and sine g of x is equals to negative sine x in the given interval. Then you answer those given questions. You can take a snapshot of that or revisit the lesson and pause it there and copy those questions and then answer them. Then your next question is question number 2. Go and practice that question also and see how far these questions take you. Otherwise, unless if there are some other questions, my lesson is about to end here. Maybe I can entertain one more question. I'll just look at one more question. This question says, "Sir, I didn't understand the points of intersection. Do you also use the value k when you look for the points of intersection?" That's a very good question. Yes, you do, because this k will help you to move from one point to the other. Remember, your general solution said 40 degrees plus k times 120 degrees. This is where that k element of integers is important. Otherwise, you won't be able to get the coordinates of A, B, and C without substituting for k. So you always use your general solution. These two graphs, blue and red, meet at those 3 points A, B, and C. So for you to get those points, you take one general solution at a time. In this case, I chose the 40 degrees plus k, 120 degrees. You substitute for k using 0 here. When k is 0, 120 times 0 is 0. Then you add to 40, you get 40 degrees. Then you go to the graph and check where can I place that 40 on the Cartesian plane. You can see it's just after 30 where these two graphs meet here. It's just after 30 where those two graphs meet there. Then if you want to know where they meet at C, you choose a 1 for k now. K is very important. In other words, these are counting numbers moving forward and going backwards. You're searching your answers going forward, 0, 1, 2, 3, 4. Those are the values of k, or -1, -2. You search going forward and search going backwards. using this 40 degrees. 40 degrees is your reference angle. Then if I want the next angle, I put k is 1. 1 times 120 will give me 120. 120 plus 40 will give me 160. That's the one that takes me to 60 degrees here. That's my 60 degrees there. 160 degrees. Then you substitute for 160 into the function, either function, just like in all other graphs. After getting the x, you substitute and get y. We are doing the same even here. Then you work backwards now. You use negative 1. Negative 1 times 120 will give you negative 120. But you have 40 minus negative 120, it will give you negative 80 degrees. That's where we see the meeting again here. That's your negative 80 degrees. To find the corresponding value of y, you substitute negative 80 into x, either in the first function or second function. But always choose the simpler one of the two. Then you'll know it's negative 0.94 as the y value. This is your y value, this is your x value. This is your x value, y value, x value, y value. So k is very, very important. It helps you generate all the points where the graphs meet using that first angle of 40 degrees. If you have exhausted 40, you come to negative 120 down here. It was another solution. But fortunately, as in our case, that 40 degrees plus k 120 already covered all the 3 points of intersection. There was no need to go to negative 120 to find other points because of the restricted domain from minus 90 to 180. Yes, that k is very important, my child. Thank you very much for that question. Otherwise, our session is going to end here, boys and girls. Thank you for attending. Let's continue working hard. You shall nail this mathematics of it. You love it. The more you work with it, the more you understand. Thank you for coming. We'll meet again at some other point in time. Goodbye.